Okay, so NHS digitisation, anybody who works on the clinical front line knows that in the old days we used to have paper notes and you could find things. I first entitled this slide "The Great Leap Backwards of Digitisation," but I thought that was probably a bit too critical, so I've called it "The Great Stumble Forwards" instead. Now, you can go to any newspaper in the country and you can pull these headings off. There is no doubt the NHS is in disarray. And staff morale, we hear, is under severe pressure. I enjoy my job, but many clearly don't. Primary care is hemorrhaging general practitioners, and any of you who have seen a GP record will understand why that might be the case. Clinical productivity is stagnant despite all the investment in technology. We know the social care partnership is under strain as well. And digitisation really has yet to deliver the professional contentment or efficiency that it could do. And any of you want to understand this, read Atul Gawande's letter or article in the New Yorker in November 2018, "Why Doctors Hate Their Computers," and it pretty much sums it up. This is a picture from Gawande's article. It shows the problem that by going to digitisation in a rush, the old-fashioned way, lots of legacy screens, lots of drop-down menus, there's in fact a mass of computer between you and your patient. And there's a number of reasons for this. There's been really very little attention to the needs of the, I said health professional user, but it could be you as a laboratory technician, it could be as a clinician, as a nurse, as a physiotherapist. Systems in general are bought by IT professionals for IT professionals, and the user really has very little say in what's going on. There is transcontinental remoteness between the users and the software developers. I work with a pretty awful system at one hospital in Southampton where the developers are based, I'm told, in Romania. So not only do we never meet them, but there's also a language difference between us and them as well. Lack of education and awareness of the use of the users of the art of good digital practice. So we know how to use our smartphones, but we don't teach medical students, allied health professionals, what to expect of excellence in IT systems. And so people put up with what they get rather than what they could have. Interface design is really pretty dreadful, and it's not the fault of the technology. It's a fault of people and systems and organizations. As you've heard from some much cleverer people than me already this morning, there's an order, you can do almost anything with technology. That's not the issue. As Kerry just said, it's how do you pull it all together and make it work? And I wish I had Kerry's magic power. So this is a good old-fashioned way of looking at data. This is actually from the very advanced Southampton clinical data system. This is a system of document management we call eDocs. It's very well established. But when I were a boy about 10 years ago, 15 years ago, when we were starting with this, we were just presented lists of documents. So patient pitches up in a clinic, you pitch up with them, and you have to spend 5 to 10 minutes assembling the record from what's in front of you. It's like going into WH Smith's to buy a newspaper, and they say, certainly, so we'll sell you a newspaper. Just go over to the shelves over there, find each of the pages for that newspaper. Oh, by the way, some of them are mislabeled or the data's not quite right, but come back to the couch when you're back to the desk when you've finished, and we'll sell you the newspaper. And this is the problem that most clinicians, most people using electronic patient record systems face all the time. They have to go back to the individual menus and find the stuff they need. So I was giving a talk in Ohio some years ago, and the Cleveland Clinic director, who you'd have thought was pretty well sitting on a huge pile of money to do things. In fact, they for their sins, they use the Epic system. And he said to me, on average, my clinicians have 7 minutes to see every patient, of which they spend 5 minutes assembling the record. So they're just sitting there at the computer with their mouse, driving it around, trying to find things. And you can guarantee in those 5 minutes, they won't find everything that they want. They'll find just about enough, just about to get by through the consultation. And so that's not a great situation to be in. And I think we could find almost any other hospital in the world where the same experience persists. Now, I'm very pro-computers, but from a very pragmatic and basic way of using them. We know that computers are great. speed of transmission of data. We can get stuff around the planet or even around the galaxy at the speed of light. We can process data now at incredible speeds, which is why you can start talking about using ChatGPT and AI in your daily life. Massive capacity for storage and recall. We've heard that about the regional data networks that are developing the NHS. We can construct dynamic imagery very, very quickly and easily. We can interact with that imagery easily. And yet, with all this clever stuff, we in the health professions use computers very badly. So I don't need to tell you what's in that photograph because I'm using your brains. Most of you will recognize there are two aeroplanes in the photograph. The thinkers around you will realize there are 3 aeroplanes in the photograph because there's one that the photograph was taken from. You'll realize that these 2 aeroplanes are, one is refueling the other. They must be going at a speed of about 500 or 600 miles per hour. We can tell a little bit about the atmospherics. We can see the clouds. We can almost work out from the geography where it might have been taken from. It's the Royal Australian Air Force aeroplane, so Google tells me, but I'm not sure if that's Australia or is it the Middle East. The picture's been taken. But my point is I didn't have to give you a manual of flight, of geography or anything else to understand in a flash what was in that photograph. You may not know the details of aeronautics and air refueling procedures, but you know what's going on there. So what I'm doing now is dragging you back from the mechanics of looking at legacy interfaces to trusting the human eye-brain interface, because the best form of AI you have is actually the computer that sits inside here and can interpret the world around you. So sight is a key element in human evolution. We all know that that's a tiger leaping at us and we know when to shut our eyes and duck. We also know that the visual field is very complex and our brains are computing massive amounts of data every second. The world changes continuously around us. The pixels coming from the human retina to our central processor at the back of the brain, the hindbrain. So our visual brain is the one that does the instant processing. It allows us to duck the tiger. And then when we take in a breath, we can push the data forward to our cortical brain and try and work out whether it was a Bengal tiger or whatever. So our basic thinking is actually done almost for us automatically in the visual brain. So the question I have for you is, can we use the visual brain to interpret the world around us in terms of clinical data? The message is that interfaces which are optimized for the human brain and for intuitive visual processing are always going to be better than things that are not, because they can tell the story in the data almost automatically before we start digging around into the weeds of what's going on. Another element I want to talk about, and Kerry touched on this at the end of her talk when she showed us some timelines, is the importance of the passage of time. Most data sets give us a snapshot of here and now, what's happening today, what happened within the last few days in this clinical history. They don't tell us the totality of what's gone on. And we're all like comets going through space. We are the comet now, but actually what happened behind us, the trail we leave behind us, is almost as important as the comet itself. So everything has a time component in the world, and time is, or at least describing the passage of time, is central to this description of the lives of almost every entity, from space, the galaxies, the birth of galaxies, the Big Bang, right down to the subatomic scale. And whether we're a business, a university, an institution, whatever, we can describe those entities by a series of parallel timelines which describe different elements, a taxonomy for that particular entity, whatever it is. And that applies to engineered systems. So it might be one of our aeroplanes. How do we get it into the air? We've got engines. We've got all sorts of other things as well. Or it may be a human life, which is where I come in. Or it may be even a single blood cell where you come in. And we can now do this visually. We go back to about 2006, National Institute of Health in the States commissioned a report from the MITRE organization where they looked at electronic health records. And in the very bad old days, which was less than 20 years ago, there were computers that had administration systems, that had nursing systems, that had lab systems, that had clinical systems, radiology. You might telephone up one or other of those systems at a time through your copper telephone network, or possibly fiber optics if you were lucky, and you dig around in them and you try and reassemble that story from those totally separate data systems. We then moved to the concept, and this is only 20 years ago now, the electronic health record, of a system where all of those information sources are pulled forward into one system. But you still had to look at the system and pull out the individual components of the system as you were constructing the electronic record, which is what I effectively showed you earlier on with that document entry chart, eDocs in Southampton. We've done one step more, come one step forward from that. We use visualization tools now, and I'll hop over here because we'll come to this in greater detail in a moment, to pull all this information from these separate components onto a single screen. So what we have effectively done is abolished the time taken to reconstruct that information by doing all the hard work behind the screen. And if those of you who follow the Government Digital Service project from back in 2010 will know, that's a key element of the National Public IT Strategy. Do the hard work elsewhere so that the user can concentrate on what they need to do, which is to look at the clinical information for whatever reason. So how did we do it? So I have a playground which is, or which has been Southampton University Hospital. It's a clinical data estate. And it's not so much me, because I only came into this about 2009, 2010, when I'd already been a surgeon for 20 odd years. But I had one or two very, very bright, very, very capable and very independent-minded people who had done a lot to construct the clinical data estate in Southampton. Now, our history goes back to the 1980s, and the Wessex Regional Health Authority and IBM got together because they wanted to move things forward. And about 60 million was spent. And a lot of lessons were learned, but the whole thing fell apart. The government didn't like it. There were inquiries in the House of Commons and various people's reputations were trashed. So not a very good outcome. Southampton sat in the margins 10 miles away watching this chaos going on up the road, learned and set its own course. So Liz Hawkin, who was I believe, a nursing director at the time, and I'm just in the process of writing a book about this, and Liz has given me a very good chapter on what went on in the 1980s, started to think about what would a future electronic patient record look like, and very far ahead of her time, I think. And they bought the Crescendo nurse management system. They bought an early patient administration system. And the best thing that they did initially, they had no idea of what we were going to do with it 20 years down the line. We're going to standardize our documents. We're going to put standard metadata. So every document from 1995 onwards had a clear time date stamp. It had a department, a discipline, and who generated the document. 25 years later, that put me in a very strong position to do what I'm going to tell you about. The next step in the 1990s was to create the concept of a hospital integrated clinical support system. HICS, a horrible name, that's what it was coined. That's what we know it as in Southampton, and we love it to bits. Early in 2000s, Alan Hales, who's the developer who's done all the hard work for me, who'd been commissioned to build HICS, wrote a superb order comms system, which we call eQuest, which is still one of its best in class nationally. It does a lot of clever things, and wrote eDocs, which is our document management system, which looks superficially like Word, but it's what goes on behind it, allows people to communicate and connect, which is the important thing. Adrian Byrne, who did a lot of work with National Digital Health Networks, succeeded Liz as Chief Information Officer in about 2004. And again, we sat back and watched chaos going on around the world. A national program for IT fell apart. Aid said we rushed to the back of the queue to be co-opted into the MP-FIT. In other words, we stayed well clear of it. And by 2009, we had all these fantastic modules, but we still had the problem of the legacy interface. Now, at this stage, I was just doing my own thing as a surgeon and a bit confused by trying to find records electronically. Went to the internet and I found this work, University of Maryland, the Lifelines concept, which was only a PhD project. It was never actually operationalized. But I looked at this and said, this is something we can do something with. Subject taxonomy, timelines for each of those taxonomies, and lots of little icons which open up to underlying data. So dynamic visualization, and straight away you get the idea, even though this is not telling us a real story about a real patient. Basically, in this model, our subject taxonomy, we put the document or the event as an icon on the screen. We give it some metadata and hover over it on a balloon, and then we can very easily navigate that space. We can visualize the space, and we can open up any document we want to do. So the Lifelines project from 2009 onwards, it was a blue skies what if project. There was no commission, there was no money in this, there was no contract, there was no grant or price specification. We just did it because we wanted to do it, and we had enough support within certain corners of the hospital to let it happen in our test environment, but using real patient data. But then the battle was actually to persuade the trust management, to persuade senior clinicians who thought that the previous system was the best way to do things, that this was worth supporting. Anyway, hard and fast forward, we succeeded. And even in 2010, this was a year after we started, we cracked it. We have this taxonomy, which is based on the 1950s taxonomy. This is just the stuff that we had in our system. It had been labelled in this way: documentation, admissions, radiology, subdivided. Just looking at that picture, if I take you forward, red line means death, top line, year of birth, 24-year-old dead. You know from just looking at that picture that this young person had a horrific series of problems, spent time of much of his life. Is it her because it's obstetrics gynecology timeline? You can just see this is a mess, and this is with data going right back to the 1990s. So the visualization element is proved. We're talking about a very complex IT system. This is University Hospital Southampton's clinical data estate. It could be any organisation in the country. What we're really talking about is the clinical data that sits in the box, which I've highlighted in red over there. Move on, 14 years, this system now sits at the centre of this state. It's a long history of battle of wills to get it adopted because it didn't have money, it didn't have the kudos with it, it's just something we did. But it was a real battle and we got there. The system now, it looks different to what I showed you in 2010. It's in modern code, it's written in .NET, it's very easy to replicate. It's now a standalone application instead of sitting tangled up with all the weeds of our IT estate and the legacy code going back 15 years. One of the problems we had to solve was that if you had a lot of documents on any one time point and any one timeline, you get a lot of overload. And we eventually came up with a system whereby we have a hybrid model. So if I just go back one, lots of these complex icons here, what we call the hot cross bun icons, that's a multi-icon. I click on it, it comes the documents underneath. So we can compress huge amounts of data onto our screen and navigate it around it in one click over any time course. So one picture's worth 1,000 words. One Lifeline's data interface is worth 1,000 pictures in effect because it's all there in front of you. The dimension behind the screen is all the data, and it's very, very quick and easy to navigate around. And we've put additional functionality. We've made the admissions central to the timeline. Because it's talk about blood, we put a blood grouping and transfusion timeline so that wherever there's data from the blood labs, the anaesthetists, for example, know what's been going on with that patient. Just quickly, we built a breast cancer data system with this integral to the data set. So every patient record has got its own version of Lifelines. With 21,000 patients we put into that. We mentioned briefly, I think Kerry mentioned Somerset Cancer Registry. Somerset Cancer Registry is a nationwide system, but it's dreadful to use for clinicians. So we basically built a module which we call Somerset Cancer Registry Enhanced. We can pull all of our data out, look at it. These are dynamic histograms. So if I click on them, I pull up the whole list underneath and behind them. We also revolutionized our multidisciplinary team meetings by this module in front of Somerset Cancer Register. And for each patient, as they come up for any meeting by any subject, whether it's breast or haematology or lymphoma or colorectal or hepatobiliary, you can read the clinic date, you can pull up clinics for the last 6 months and the next 3 months, and we've built in a link to the Lifelines for that patient. So within the MDT, you've got both the records plus all the clinical records at a single click. So you can do in a minute or two per patient what would used to take 5 to 10 minutes to do. So just to summarize it then, it's a transformative system. It's really been optimized for the end user, and that's been done using an agile and iterative technique where the programmer and the user experience person, which is me, talk to each other, often by email at 1 o'clock in the morning when we suddenly had ideas which work. So whether you can replicate that in the big real world, I'm not so sure. But we finally persuaded the trust that this was better than anything else. Our current chief clinical informatics officer is a fan. As a result of it, the system is now there. And if you work in Southampton University Hospital, you can see your clinical records on a single click. So I'd like to suggest that this is a first-in-class exemplar for dynamic data visualization in many other applications. In fact, this is global in its application if you think it through, because you can do this for anything once you've got the data sets. The coding is easy. It's the principles behind it which you have to grasp. And then there's a framework for machine learning and predictive analytics. I've already shown you how you can read with the human brain story in the brain. So is this a fast track to AI? If we just put mathematical data onto those icons and look at the patterns with them, we can get most of the way to the diagnosis. One of the games I play with my friends when we're demonstrating the system is they pull up a record I've never seen before and say, tell us the story behind that. And you can do that. So if I can do it with my professional experience, then the AI should be able to do it as well. So that opens up all sorts of interesting opportunities. And I think that this is something that we could talk about in AI because it simplifies the whole AI process. You no longer have to pass the patient's name, address, date of birth. You can just do it from the iconography, which is anonymized, and that brings up many other opportunities as well. So my final slide, the NHS is in disarray. Why? In part because information is still siloed, systems are disjointed and disconnected, and Jean-Baptiste talked about that earlier on. Staff morale is under severe pressure, and a lot of that is down to the grim grind of driving a mouse around a screen, of logging in with your password 20 to 30 times a day and being locked out every 5 minutes for security. Primary care, well, any of you who've seen primary care records will understand the grim work that the GPs have to do just to navigate around your record each day. Clinical productivity is stagnant. Well, of course it is, because we're spending most of our time doing nothing on computer screens, but reassembling what the computers can do for us. The NHS Social Care Partnership, well, we've talked about suboptimal information flows and joining things up, and it can happen. And we can build onto our interface the social care data as well. And in fact, Southampton Council started to do this a few years ago, but then the chap who was doing it moved on and the whole project fell apart. So can we answer Atul Gandhi's problem? Digitization has yet to deliver professional content or efficiency. Well, we're on the way, but we've shown that there are better solutions are possible, and it doesn't cost very much to do it. It's just a leap of imagination is all you need. So it was a stormy course to get there. It throws up lots of ideas, and hopefully over the next couple of days we can have some discussions about that. I hope that was of interest. The reason I want Kerry's superpower is that I want this to get out into the bigger, wider world. And that's a real challenge in the NHS. Innovation is not easy. Thanks very much.